Okay, so now let's start the presentation. The topic what I've selected is challenges faced for design of industrial structures and way forward. First of all, let me explain why I have considered this topic. And before we get into the presentation, I would like to share a brief incident which happened at early start of my career. I was quite fortunate to work with a 70-year-old mentor. In one of the evening time, he said, Bhavin, I have learned only one thing after spending more than 40 years of timeline in structural engineering. So my eyes and ears were open, and then I asked him, Sir, please give me insight of that area. And then he said that any design calculation you give me, I can prove it right, and at the same time, I can prove it wrong. So what he was trying to tell that the structural engineering is not an exact science. The conceptual thinking and engineering judgment are very much important whenever we are performing structural analysis and design. So with this perspective, we are going to focus today on the industrial structures. And before starting my session, now this is what I am telling on the lighter note that if you give me any design calculations of any consultant across the country, then within 2 minutes of time, it can be said that the design calculation is not compliant with XYZ clause of the certain code. Okay, so with this perspective, today we'll be focusing on the industrial structures. And when we talk about industrial structures, there are many areas involved, but today we are going to focus on the earthquake resistant design of industrial structures. So when we talk about industrial structures, earthquake resistant design is only one of the important area. There are many other areas which we should be taken care. Now, why earthquake resistant design is important for industrial structures? Because industrial structures are highly irregular due to abrupt change of mass and stiffness to meet the functional requirements. Now, when we talk about earthquake resistant design of industrial structures, generally whatever structural systems which are used can be divided in two categories. One is the moment resisting frames, and second is the braced frame structure. Now, in my opinion, both these systems are not efficient from the earthquake resistant design perspective. So if we talk about moment resisting frames, it is too flexible when it has to meet the functional requirements of, say, meeting the drift criteria. On the other hand, when we talk about the braced frame structure, it is relatively very good system. It is relatively rigid as compared to the moment resisting frame. But what when we are designing the braced frame structure, the bracing what we are considering in the analysis, it is having substantially different capacity in the compression force and tension force. So what is happening that whatever member is, say, is resisting tension in one of the earthquake cycle, but in the reverse cycle it will be having the compression. And now since in the compression the capacity is too low, the brace size will increase. And since the brace size will increase, the structure will become more rigid. And since the structure will become rigid, it will attract more earthquake forces. So this circle will go on and on. So there should be some intermediate structural system. And for that, recently I have registered myself for doing PhD. So definitely we'll be discussing about those innovative structural systems maybe in the future sessions. But in the today's session, we are going to focus on the conventional structural systems. Now, what is being shown in this slide is the sequence of release of the Indian Standard Codes. So, if you see very quickly, then in 2008, BIS published IS 800 2007 for design of steel structures. Then BIS published IS 15988 2013 for the retrofitting of the RC structure in 2013. Thereafter, in 2015, BIS published IS 1893 Part 4, which is exclusively for the industrial structures. And thereafter, in July 2016, IS 13920 was released, and thereafter, BIS published 1893 Part 1. So, when we talk about earthquake engineering or say earthquake resistant design, these are the three important pillars which should be taken care simultaneously. That is, a design, detailing, and the execution. In one of the session, I received this question from one of the engineer that why Indian standard codes are getting revised. What was the argument he put forward that whatever structures we have designed using old codes, they are performing very well. Then why is it required? And I have tried to answer his question with this slide. Now, what we see on this slide is the brief history of IS 800 code. Now, if we plot history of the other code, then I think it would be more or less similar to those which is being plotted for IS 800. If we talk about IS 800, it was firstly published in 1956. Thereafter, it was revised in 1962. Then it was revised in 1968. And then up to 1984, it was working stress design method code. Okay. Now, when we see the global trend on the similar graph, which is shown with the purple color line, then in 1986, the limited design method was introduced. And from 1986 to say till today, the American standard has been revised for more than 5 times. And when we talk about our code, it was in 2007 with the limited design method, which was the first revision with the limited design method. And thereafter there is no revision which has happened after 2007. So what is shown in the figure is a red color hatch area, which is a big gap to be covered, because always we are trying to align our practices with the global practices. So whenever these codes are getting revised, there is a huge gap what we see, because the updation cycle of the code is in range of 10 to 15 years. So within 10 to 15 years, the global practices would have moved very farther distance. So that is what we have to catch up whenever the next revision is happening, right? Now, what is shown in this slide is the interface between different IS codes. I believe this is very much important area, because whenever the revision of Indian standard codes is happening, then if revision cycle is different, for example, the revision is happening in a different period of time, then there may be possible conflicts between two codes. So that is the important area which we have to look into whenever we are performing the design. So always whenever there are revisions in the code, there are questions in the minds of structural engineers, right? And I believe that all these kind of questions can be answered if we try to understand the overall philosophical angle of the code. And at the same time, in my opinion, it is very much important and the overall philosophy of the code. So when we talk about the overall philosophy of the code, then in my opinion, now we have started migrating from the force control philosophy to the displacement control philosophy. Generally, for all structures, we are carrying out first order elastic analysis. And in my opinion, there are major drawbacks in the elastic design. Like, first is the reserved strength beyond elastic limit is not quantified. And second thing is the collapse mechanism is not known. Okay, so coming back to our main topic, main theme today, is what we are going to focus now in the next 20-25 minutes is I'm trying to highlight the few important clauses of IS 800, IS 1893 Part 4, IS 1893 Part 1, and IS 13920, which is creating a practical difficulties for design of industrial structures, in my opinion. Again, it's not an exhaustive collation what I have made right now, but I have picked up certain clauses which is creating a trouble, or say which is creating practical difficulties while performing the design of industrial structures. Okay, thank you, Rajiv. So firstly, we will start with IS 800 2007. When we talk about earthquake resistant design, then section 12 was introduced in IS 800 code for earthquake resistant design of the structures. And till today, I am receiving many questions like whether Section 12 is applicable for the structure under consideration. If Section 12 is applicable, then which clauses of Section 12 are applicable? And if certain clauses of Section 12 are applicable, then how to actually perform the analysis or design using those clauses? Right? So these kind of questions we have whenever we are performing design with the Section 12. So when we refer earthquake resistant design, as per section 12, it is said that the steel frames shall be designed and detailed to give them adequate strength, stability, and ductility to resist severe earthquakes in all zones without collapse. That means whatever design we will perform, that is for the collapse prevention stage. And the response reduction factors are mentioned in table 23 of the code, which are different than IS 1893 code. So if we are referring response reduction factor from section 12, then we have to exactly refer section 12 for the detailing part, right? Okay, so this is a very much interesting slide now. This is clause number 12.7 for ordinary concentrically braced frames. Now, what is said in this clause that inelastic deformation corresponding to joint rotation of at least 0.02 radians without degradation in strength and stiffness below the full yield value should be demonstrated. So what does it mean that we have to carry out inelastic analysis corresponding to joint rotation of say 0.02 radians and 0.04 radians? Now from where this 0.02 radians and 0.024 radians have come, if you refer the 1994 Northridge earthquake, then at that time the actual joint rotations were measured for all beam column junctions, and from that these values were derived in the international codes, and thereafter almost 120 or say more than 120 connections were tested. Full scale testing was done, and based on that the recommendations were made and standard details were created for all beam column junction details. Okay, so but what is presented in Indian Standard Code right now is only one clause. So there are two parts to this clause. That first of all, in analysis, in my opinion, we have to go for the inelastic design, and whenever it comes to detailing, we have to go for the specialized detailing to ensure that the my joint is able to resist the identified the rotation. And joint rotation values are presented in on the slide. Like if I have ordinary concentrically braced frame, then this is 0.02 radians. If it's a specially concentrically braced frame, then it is a 0.04 radians. And similarly for OMF it is 0.02 radians, and for SMF it is 0.04 radians. Now we'll not go to in much depth of each clause right now. I'm just what I'm trying right now, I'm just trying to highlight different important clauses of the code, and for each clause definitely we can have a detailed discussion, maybe in the subsequent sessions. When we refer to the bracing members in section 12, it is said that the slenderness of the bracing members shall not exceed 120. Now this 120 value has come again from the discussion like what we had in the initial part of the presentation, that the whenever we talk about bracing member, it is having substantially different capacity for resisting compression and tension. So that's why there is a stringent limit of the slenderness ratio on the bracing member whenever we are talking about earthquake resistant design. For beam and column junction, if we refer clause number 12.11.3 for specially moment resisting frames, then this is a strong column weak beam concept which is introduced in the IS 800 2007 section 12. What does it mean? That my column should have at least 1.2 times capacity, which is greater than the connected beams. The clause number 12.12 is talking about column basis. So in my opinion, what might have been considered that the column based junction is one of the area where plastic joint may be generated during extreme seismic event. So for that, it is said in the code that if I am having a fixed column base, then anchor bolts should be designed to withstand moment of 1.2 times the full plastic moment capacity of the column sections. Now, if we design exactly as per this clause, then it may result in the impractical sizes of the anchor bolts and the base plate in certain cases. Okay, so this was a brief about IS 800. Now let's move to IS 1893 Part 4, which was released which was rather revised in 2015, and it is specifically for the industrial structures. Now, what we see on the screen that the DBE and MCE concept is still there in this code. Now, it is again because of the same problem what we were discussing about the interface between different code, because IS 1893 part 1 is recently revised like in say 2016 or 2017, and this code was revised in 2015. So we will see that there are major philosophical difference between two codes. For vertical acceleration, it is said in the code that we have to consider the vertical acceleration, and then if its effects are not significant on my design and analysis results, only in that case I can ignore the vertical acceleration or say vertical forces generated from the earthquake. So that means in all the cases I have to consider the vertical earthquake forces. This is the most important table of the code, I believe, which is a table 2. Now it is highlighting, firstly, it is highlighting different damping values for the RCC as well as for the steel structure. RCC damping value is 5%, and for the steel structure damping value is 2%. And I hope you may be aware that in the code, the all the structures are divided in 4 categories. When we talk about category 1, that means those are the most important structure. And when we move from category 1 to category 4, then the importance of the structure decreases. Now, in the similar table, the structural analysis methods are also suggested. And it is said that the nonlinear time history analysis shall be carried out for verifying the collapse mechanism. And similarly, just in the adjacent column, the structural design is also mentioned. And it is said that for the steel structure, we have to go for the plastic design. So if we refer clause number 8.3.1 of the code, then it shows the load factors for the plastic design of steel structures. And here we can observe that the load factor is 1.7 times. Okay, when we refer to clause number 8.3.2.1.1, what it says that if my structure is not regular, that means if the distribution of mass and stiffness in plan is not symmetrical about x and y directions, then all the earthquake forces in 3 directions may be combined simultaneously. Now, when we talk about industrial structures, all industrial structures will be definitely highly irregular. So we might have to go for combining earthquake forces in 3 directions simultaneously as per this clause. This is a very important clause. It is talking about soil structure interaction. Now, what is said in this clause that the soil structure interaction may not be considered in the seismic analysis for structures which are supported on rock or the hard soil. That means whenever I have n greater than 50 and when the shear wave velocity is greater than 760 meter per second, I need not consider the soil structure interaction. But what does it mean that for the majority of these structures, we might have to consider soil structure interaction, because whenever structure is supported on say medium soil or soft soil, then the soil structure interaction is required as per this clause. Clause number 9.2 of the code, which requires the interaction effects between the structure and equipment. So, whenever during the extreme seismic event, the coupling criteria are defined for the different categories of structures in Annexure B, which should be considered for the analysis and design. Okay, so when we talk about clause number 9.3, it is talking about time period estimation, and now and it is said in this clause that formula which is given in IS 1893 part 1 for estimation of time period of buildings are not applicable for the industrial structures. Okay, let's go ahead. So what is said in this clause that whatever time period we are getting from the computer model shall be considered for estimation of the earthquake forces. So in my opinion, whatever model we create, that should be thoroughly represent the distribution of mass and stiffness. So then and then we will be able to reasonably estimate the time period of the structure. So if there is any error in estimating, say, time period of the structure, then the design may err on the conservative side or it may err on the unconservative side. So I think this is very important clause when we talk about dynamic analysis. Now this is also one more important revision which is made in the code. It says that the p delta effect is mandatory for all kind of structures. That means irrespective of the category and irrespective of the zone in which they are located. So in short, p delta analysis is to be performed for all industrial structures. The clause number 10.1 and 10.2 is identifying the requirement of the non-linear time history analysis, what we just discussed in the table 2 of the code. So as per this clause, if my structure is in category 1, then irrespective of zone, I have to perform non-linear time history analysis for verifying collapse mechanism. In clause number 10.1, the time history analysis method is defined, but it is just only small para which is included in the code. So I believe it needs to be elaborated so that more details should be there when that how to perform this non-linear time history analysis and which are the parameters based on which we should study this collapse mechanism for safety against collapse. If you refer clause number 10.4.1 of the code, then it is said that we can consider the plan bracing or say we can consider the RCC flooring as a rigid system only in the case where properly designed floor bracings are provided. And secondly, also it is said that the cutouts at that level should be less than 25%. This is very important slide because we all know that in IS 1893 part 1 the damping is now constant irrespective of the material, but when we refer IS 1893 part 4, which is for industrial structures, there are different damping values which are given. So standard spectra which is given in the code, it is for the 5% damping, and then suitable amplification factors are given for the different damping values. If you refer annexure B of the code, then it is said that the weighted average of corrected n value or say shear wave velocity up to 30 meters shall be considered. That means for classifying the soil type, whether it is a soft soil or say hard soil, n values up to or say shear wave velocity up to 30 meters shall be considered. So that means that we have to go for minimum borehole depth up to 30 meter across the site. Okay, so this was quick brief about IS 1893 Part 4 2015, for which is exclusively for the industrial structures. Now let us quickly run through the IS 1893 Part 1 2016. Again, our perspective is industrial structures only, so I will highlight only few important clauses. Firstly, as we have discussed, DBE and MCE concept is now removed from the forward in part 1. Now, in part 1, clause number 6.4.3.1, the stiffness modified factors are mentioned. And there is only unique value of stiffness modifier factor for different cases is suggested. So, in my opinion, these stiffness modifier factors should be considered only for the seismic load case. If we consider the same modifier value for the dead load live load case also, then my results for the large span beam may be erring on the unconservative side. That means the span moment whichever I will be getting would be on the unconservative side in this cases. So whenever we are using these stiffness modifier, we should be careful because those are unique values given in the code. The clause number 7.1, we all know that it talks about all kind of irregularities like plan irregularity, vertical irregularity. And for each irregularity, the mathematical limits are identified, type of analysis is suggested, as well as drift limit is mentioned in the code. So, in my opinion, this limit should be further demarcated, maybe based on the importance of the structure, based on the category of the structures for the industrial structures, or maybe height of the structure, maybe based on the earthquake zone, etc. Can be done with respect to industrial structures. Damping ratio, already we have discussed in the previous slide that now it is a 5 percentage for irrespective of the material of the construction. Okay, so now we are coming to IS 13920 2016. Again, our focus is on the industrial structures, and I will again try to highlight few important clauses from that perspective. Now, we all know that in 13920 2016, the geometric constraints are imposed on the cross section of the flexural members. And the title is now revised to reflect the design provisions which are added in the revised code. For industrial structures, generally a precast RC structure was one of the preferred option to achieve the speed in construction. So if you refer the clause number 1.1.2 of the code, it is said that the adequacy of the design system, which is different than the say monolithic moment resisting frame structure, then those adequacy of such system shall be demonstrated by adequate, appropriate experimentation as well as with the nonlinear dynamic analysis. This we all know that in clause number 6.3.4 as well as in 6.3.5.3, this is what is mentioned. But what is said that the concrete in RC section to be ignored for calculation of the shear capacity. The in clause number 7.1.1, the 20 dB criteria is mentioned. And in the amendment now it is revised as a 20 dB and the figure is corrected. If my cross section is having a certain aspect ratio, like for example, if I have a 350 mm by 900 mm column, then I need to consider the distortional shear as per this clause. Okay, this is the most important part, which talks about the relative strength of beams and columns at a joint. So it is basically strong column and weak beam concept. So as per the code, the strength of column should be 1.4 times higher than the weak than the beam capacity, or rather beam which are connected to the column in the particular principal direction. Now there are practical difficulties when we have a large span beams. The sizes of columns may go sometimes impractical. So we need to consider this clause. Okay, Jai Doshi has asked that shouldn't the stiffness modifiers for steel structures be I gross of beams and columns, that is value should be taken equal to 1. You are absolutely right, Jai, that for steel structures it is mentioned that we have to consider I gross as a 1. But when we talk about industrial structures, we are focusing on the steel structure as well as the concrete structure. So if I have a concrete structure, then I have to consider the correct moment of inertia. For steel structure, definitely the value should be 1. Okay, I hope I have answered your question. So what we have discussed so far, I've just tried to collate a few important clauses of the from the different codes. Again, this is not an exhaustive summary. I have tried to collate a few important clauses, like what we have discussed, that inelastic displacement corresponding to joint rotation is required. We discussed a little bit about plastic design of steel structures, design of anchor bolts, non-linear time history analysis, P delta analysis, soil structure interaction, crack moment of inertia, strong column, weak beam concept, etc. Okay, so when we are mixing everything together into the design structure, this is my personal opinion. Sometimes maybe conceptual thinking is lost, or maybe engineering judgment may not go into the appropriate. And so it is very much important that we understand the overall holistic approach while applying all different clauses from the different IS codes. Okay, right. So this was quick summary of different clauses which may give practical difficulties. Now, what should be way forward out of this? So, based on my understanding, I have created few slides showing the way forward. I believe it is greater transition in the design practice as compared to the transition which was witnessed in 2002, which is after Bhuj earthquake 2001. I believe it is a time for all structural engineers to gear up for bridging the gap between the latest methods, practices suggested in the revised codes versus the current industrial practices. And for implementation of the code, as we have just discussed a couple of slides ago, that more communication is required between structural engineers fraternity for resolving doubts, queries, etc. And it is very much important to understand the overall philosophy of the code, in my opinion. This also we have discussed that the interface between different IS codes is a very much important area. Now, this is very much important that whatever software we are using, those software must be authenticated. Like whether the software is performing the design or analysis exactly as per the updated Indian standard or not. So, so based on the authentication exercises, if we found that these are the clauses, if they are not included, then we might have to do something, some precautions we have to take manually before we release the drawings for the construction. So in short, what I mean to say that the structural engineer should be aware about the limitations of the software being used while performing the design. In any case, I believe that the reinforcement detailing for RCC structures and connection detailing for steel structure is of very much important for resisting earthquake forces. So attention should be given in the drawings, and also the same should be followed at site. Now, this is the important question. What if we have the comments, doubts, queries on the published IS codes? So we all know the overall process of IS code formation, like the committee is prepared at a national level, which is inclusive of users, technologists, manufacturers, design engineers, academicians, etc. And thereafter, draft is being circulated to all engineers across the country, and then based on the comments feedback, the document is revised. But so this is what my suggestion is. If you have the comments, doubts related to IS codes, then you may forward your doubts at this email address, and we may arrange such live Facebook sessions, particularly for each class. And thereafter, we may send the collated discussion to technical committee of BIS, maybe in this format, wherein we can mention the different clauses, the modified comments or wordings, and again the justification of the proposed change. So what we may do, I think we may consider the real time problems, and then we can work out with the different clauses, and then based on that we may suggest certain modification with the real facts and figures. Okay, so now we are coming to the end of this presentation. So this is what all from my side. Now I'll be taking a few questions randomly, and still you have further questions, then your feedback, etc., everything is welcome. I have mentioned my email address there. So thank you all for the participation. Now if you have specific questions, you may please write in the comment section. Yes, Mohammed, you have written that please do give a PPT of a PDF of the presentation. So certainly that will be circulated, as well as the entire session is getting recorded, so we will be publishing the recorded session also. Okay, so Mayank, what is your question? And also design some members according to AISC code and pricing, etc. from Indian codes code. How appropriate is this? Okay, Mayank has asked a very good question that how about if we design certain members using American codes and then certain members may be using the Indian standard code. So in my opinion personally, we should not mix two codes together, because that is one of the essence of this presentation, that first of all the overall philosophy of different code is significantly different. So when we are just picking up random clauses from the different codes, then the overall design philosophy of one code may not match with the another code philosophy, and then our design may either err on the unconservative side or the conservative side. And when we talk about American codes or say other developed country codes, they have a better fabrication control, they have better welding control, they have better raw material available in their country. So their partial safety factors are relatively lower as compared to the our country. So definitely, in my opinion, we should not mix a couple of codes together. Okay, let me take another question now. Thanks, Dushyant. So Udit is asking that in design of pinned bases, 1.2 times shear capacity of column should be considered for design of anchor bolt. So shear capacity of column should be calculated considering the web area only, or web plus flange area. I think you may include the flange area also, but the majority of the shear is taken by web portion only. So I think it will not matter much probably in the your final outcome, in my opinion. Thanks, Sanjay. We will definitely share the copy. Okay, what is the question? Bridges is asking that in design of RCC structure, consider stiffness modifiers as beam and column 0.35 and 7 or 1. See, that's what we have discussed, that if we are talking about RCC structure, then as per IS 1893 part 1, there are unique values of the modifier, which is 0.35 and zero point 0.7. Now, let us try to understand quickly why it is 0.35 and zero point 0.7. When I am making this modifier as a zero point 0.7 for column and 0.35 for the beam, then what will happen in the moment distribution pattern, that my column will be relatively stronger than the beam. So the moment which will be transferred to the beam junction will be substantially higher as compared to what I consider 1 on both the sides. So in my opinion, for the seismic analysis, definitely this value 0.35 and zero point 0.7 should be considered. But whenever we are talking about RC structure for dead load and live load case, then in that case, my opinion 1 is a better option. Okay, let me pick up another question randomly. Okay, INSDEC India has asked a very good question. Like, is there any flowchart which specifies the designs considering all the discussed codes? I think that is the bigger issue what we have, that we do not have such kind of flowchart, and that's where we may end up, you know, in a big trouble if we are not, or rather, if you do not understand the overall philosophy of the code. So there may be major problem, but you have raised a very good question, and but it is still not available, and I think we should prepare it, and that would be a great help to the engineers. Okay, Hiren Desai is asking about limitations which I have come across of different software. Kindly share the highlight in other session for benefits of fraternity. Definitely, we will have separate session specifically on the software, and we will highlight what are the practical difficulties and how and which clauses are really not included. Krishna Sahakari, thank you very much for the participation. Okay, Cam is asking that the shear value in case of highest code area are very stringent in, and so many beams are failing. So if we design the same using BS code, it passes. So that's what, you know, the bigger problem is that if see, that could be one of the reasons that the partial safety factor could be different, and another way would be that our codes are updated, say, in 2007. Now, when the code was updated in 2007, the process might have been started, before 10, 15 years. So when we talk about the global design practices as of today, there will be significant difference in the different clauses, and that may give this kind of error. So I think we should get into each kind this kind of clauses. We should take real time example, and we should, first of all, we should try to convince ourselves which is better one, and then we can take a call. Okay, Narendra Savarkar is talking about fire resistance. For fire resistance is a very good topic. It's a very good question you have asked. And in IS 800 2007, now there is a separate chapter specifically on the fire resistance. Abhinandan Khanna is asking what to do when we have limited column size and steel reinforcement is higher than 4%. Yeah, it is very simple that you have to increase the column size, and then you should not succumb under the pressure. That's what I can say. Because if your reinforcement is getting more than 4%, then practically it cannot be executed on the site. Now, even if, for example, you are releasing the drawings and then the execution is happening, then just imagine if there is no place for the proper concreting. So in my opinion, even after putting so much reinforcement, the whole purpose of the earthquake resistant design will be lost, because there may be honeycombing, or say because of the improper concreting, the durability will be also very less. So in my opinion, the column size is increased, or alternatively you may look for the different structural system. Okay, Mayank is asking, can we also arrange sessions for software compatibility of Indian codes so that new engineers become more comfortable in design? It's a very good suggestion, and I am planning for it very shortly. I will announce it, and then we can have a very detailed discussion on the software versus Indian standard codes. Thank you for your suggestion. Okay, Krupa is asking, what is the philosophy behind 20 dB column size criteria? So whenever we have a RCC structure, and when we talk about beam column junction, the reinforcement of the beam will be anchored in the column, right? And if you refer to the other international standards, it is said that whenever we are anchoring our reinforcement, the bearing check should be carried out. Now, bearing check is one of the complex area now, which is not included in our code right now. But what is said, based on those kind of bearing checks, some values has been suggested, like a 20 dB. So it is specifically for the bearing check of the reinforcement. Okay, Shefali is sorry. I think it is a Shubham who is asking that the IS code has no clause for the pushover analysis. You are absolutely right. Till today, IS code doesn't have any specific clause for pushover analysis. But see, whatever we have discussed right now, when we specify IA, or rather, when we talk about IS 193 Part 4 for the industrial structures, we have discussed about the non-linear time history analysis. Now, for that non-linear time history analysis, we will have to go for the pushover analysis only. And in IS 800 2007 also, we have discussed. Now, it was incorporated in the code since 2008, that we have to design the structure for the inelastic displacement corresponding to the joint rotation of, say, zero point 0.02 to zero point 0.04 radians. So that means the pushover analysis is on since 2008, in my opinion. Yeah, I hope I have answered your question. Okay, Sefali is asking, could not attend the whole session. Would it be looking for recorded version? Yeah, certainly the recorded version will be shared with you soon. Okay, there is one more suggestion for the response spectrum analysis in buildings. Definitely, we can have. This is a very good topic which you have selected, because for majority of the industrial structures, we will have to go for the response spectrum analysis. And now, if we really do not understand the fundamentals of the response spectrum analysis, then the design could go on the either side. So it's a very good topic. Okay, so now, okay, thank you, Tushar. Okay, Kim, you have asked a very good question, and I think probably I have answered your question, that whenever, see, any Indian standard code is getting revised, it is taking cycle of 10 to 15 years. So the revision is actually starting before 10 years, when we actually get the draft copy of the code. So prevailing practices during that period is being taken care. So definitely we might face this kind of major gaps between when we compared our Indian standard code with the international code. Ravindra is asking, do we have any clauses for the cold formed member design? For the cold formed member design, I believe we should refer IAS 801. Okay, thank you, Rishikesh, for appreciating the efforts. Okay, so with these, we have reached to end of the presentation. So still, if you have many queries, I think the questions are still floating. So I will suggest that you may either forward me on the email whatever I have suggested in the presentation, or you may write down in the comment box whenever this video is getting published. Okay, so thank you all for the participation and making this as a successful event.